Example 3 says, find the volume of the solid formed by rotating the region bounded by y equals x squared and y equals x plus 2 about the line x equals 3. So here's my y-axis, here's my x-axis. Y equals x squared looks something like that. Y equals x plus 2 looks something like that. So I need to figure out where do those two curves intersect. So I'm going to do that by taking x squared and setting it equal to x plus 2. If I subtract x and 2 on both sides, we get a quadratic equation. I can factor this into x minus 2 times x plus 1. And we end up getting that x equals 2 and x equals negative 1. So that is negative 1 there, and that is 2 there. And I want to rotate this about the line x equals 3, which let's say is right there. And I need to do some erasing so that I can have more room. Alright, so here I went ahead and I rotated about the line x equals 3, and we get this kind of image here. And if I'm setting up my integral, I have the volume is equal to the definite integral from a to b of 2 pi times the radius times the height times the thickness. And so here, let's see, I'm going to factor out 2 pi, and then my limits of integration should go from negative 1 to positive 2. And now the next thing we want is the radius. And remember, the radius is the distance from my shell to my axis of rotation. So here, I want to find out what that thing is. And I know that the distance from here to here, so my y-axis to my shell, I know that that distance is x. And I know that this total distance here is 3, because that's the distance between my y-axis and my axis of rotation. So if x plus r is equal to 3, then that implies that my radius is 3 minus x. Okay. And now I want to go ahead and I want to think about the height. So I'm going to do a little bit of erasing. That was a little bit more erasing than I wanted it to be, but that's okay. So the height is the distance from the top to the bottom of my rectangle, and I'm going to call that h. And notice that the bottom of my rectangle does not go down to the x-axis. So we kind of saw some stuff like this in the section on area between curves. And so my value for h here is equal to my upper curve minus my lower curve. And my upper curve in this scenario is the linear one. So it's going to be x plus 2. And then my lower curve is the parabola, so that would be x squared. And so that is what we are looking at. So here I'll put x plus 2 minus x squared, and I want that in parentheses to represent my height. And then my thickness is dx in this scenario. Okay, so I've taken my integrand here and I've expanded it out. And so now we have 2 pi times the definite integral from negative 1 to 2 of the integrand x cubed minus 4x squared plus x plus 6 all times dx. And I'm just going to let you know that if you evaluate this integral, it ends up coming out to be 45 pi over 2. So that is the volume of this three-dimensional shape. Example 4 says, set up an integral that finds the volume of the solid formed by rotating the region bounded by y equals the square root of x plus 4 x equals 0 and y equals 0 about the x-axis using the disk method. So even though in this section we're learning about the shell method, this example asks us to use the disk method. So let's go ahead and do that. I'm going to go ahead and draw my axes, and notice that this curve here is a transformation of the curve y equals the square root of x. What kind of transformation is it? Well, if we have that we're adding 4 to the input, that means that it's going to be a shift left 4 units. So our parent graph normally starts at the origin, or has an x-intercept at the origin. So now our x-intercept will be at -4, 0. And it's going to look something like that. Here's my y-axis, here's my x-axis. This is my x-axis, this is my y-axis, so I want to stop there. And we are rotating about the x-axis. So I'm going to put my little rotation symbol there. And it's going to look something like that. And imagine the three-dimensional shape that this creates. One time I asked my students in a previous class what shape that makes, and they said that it looks like Bullet Bill. And Bullet Bill is a character from Mario. So kind of looks like that, and it has teeth. Anyways, that's what the three-dimensional shape looks like. And we want to find the volume of it using the disk method. So I'm going to go ahead and I'm going to draw a cross-section. So the cross-section is a disk, and it has some thickness to it because it's a three-dimensional disk. And the thickness there is delta x. And now I just want the radius of my disk. So that's the distance from there to there. And I can call this point x, y. So my volume is equal to pi times the integral from a to b of my radius of the disk squared dx. So let's figure out what the radius should be. Looks like my radius is whatever my y value is, but because we're integrating with respect to x, I'm going to need, instead of y, I'm going to write this as x plus 4, and we're squaring that quantity, and we have dx. Now I want to figure out what are my limits of integration. So if I'm drawing disks, my leftmost disk starts at x equals -4, and then my last disk is going to end here at x equals 0. So I have -4 to 0 there. And let's go ahead and clean that up. I have pi times the definite integral from -4 to 0 of, if I square the square root of x plus 4, I get x plus 4 dx. And this question just asks us to set up the integral that finds the volume. So this is our final answer. However, I want to go ahead and actually solve this integral, and you'll see why in just a moment, but let's go ahead and take the antiderivative. And I'm evaluating this thing between x equals 0 and x equals 4. So that's equal to pi times, let's see, 4 squared is 16 over 2 plus 4 times 4 is 16. I am now realizing that I plugged in the wrong limits of integration. Please excuse my error. Okay, so now I am plugging in 0, so that's going to be 0 minus, and then now we're plugging in -4, so that's going to be 16 over 2 minus 16. Okay, that's looking better. So, let's see, we have pi times -8 minus 16, that's equal to 8 minus 16 is -8, -8 is +8, so this is going to simplify to be 8 pi. And again, this question really just asked us to set up the definite integral that would find the volume, but I solved it because of the next example that we're going to take a look at. So this is example 5. It says, set up an integral that finds the volume of the solid form by rotating the region bounded by y equals the square root of x plus 4, x equals 0, and y equals 0 about the x-axis. So this is the exact same example from just a moment ago, except now we're using the shell method. So I'm going to go ahead and graph this. All right, so I've gone ahead and I've graphed this. I'm rotating about the x-axis, and we have that. So now what I'm going to do is I am going to draw a rectangle to represent one of my shells. And the thickness of this is delta y, which means that we are going to be integrating with respect to y. So in this particular instance, because we are using the shell method, we're going to be integrating with respect to y, which is why I'm putting dy here. And now what we want to do is we want the height and the radius of our shell. So the radius of our shell is the distance between the shell and the axis of rotation. So I want that distance, which I'll call r. And remember, this point here is x comma y. And we also want the height of our shell, which is the distance from our point there to the y-axis. So I'm going to call that our height. And we're going to go ahead and set up our integral. So we have 2 pi. I factored that out since that's a constant. And then my limits of integration are going to start at 0. And then the place that they're going to end is related to the y-intercept of our curve here. And if we don't know what that is, we can plug in 0 for x. So this ordered pair right here is 0, 2, which means that my upper limit of integration is going to be 2. Now I want the radius, and I want the height, and I want the thickness. Now be careful, our thickness here is dy because we're integrating with respect to y. And our radius is should be y. So you have 2 pi times the integral from 0 to 2. Our radius, so this distance is y, which is our radius, so that's going to be y. And then what is the height? Now, be very careful here. So notice that the entire region that we're looking at is in quadrant 2. So I'm going to take my highlighter, and this is the entire region that we originally had that was bounded by our x-axis, our y-axis, and our curve. And what's true about that yellow highlighted region is that it is limited to quadrant 2. And what's true about quadrant 2? Well, in quadrant 2, our x value is always going to be negative, and our y value in quadrant 2 is always going to be a positive number. Right now we're thinking about height, and it kind of seems like our height would be x, because isn't that just the distance from our y-axis here to this point? And it's actually not x, because distance has to be positive. Since we're talking about height, which represents a distance, that number needs to be positive. And so one way that you could think about it is you could think about it as the absolute value of x, but because x is a negative number, what that ends up becoming is negative x. But also we run into the issue that we're integrating with respect to y, so it'd probably be helpful if we solved our curve. So we have y equals the square root of x plus 4. I'm going to go ahead and solve this for x by squaring both sides. And then I'm going to subtract 4 on both sides, so I get x equals y squared minus 4. Now, what I could do here is I could factor out that negative, and if I did that, we'd get negative 2 pi times 0 to 2, times the definite integral from 0 to 2 of y times, and we factored out the negative sign, so I could just sub in y squared minus 4 here. And then volume equals negative 2 pi times the definite integral from 0 to 2. If I distribute in my y, we're going to get y cubed minus 4y dy. And again, this one only says to set up the integral, so this is technically our final answer. But why don't we go ahead and integrate it just to make sure that we did this correctly? So I've started integrating here, and let's do some simplification now. So I have negative 2 pi times 2 to the 4th is 16 divided by 4 is 4, and then minus 16. I made another error, so this should be squared, not cubed. So then 2 squared is 4, 4 times 2 is 8, so this should be an 8. That looks better. Okay, so now I have negative 2 pi times 4 minus 8 is negative 4, and a negative times a negative is a positive, and that ends up giving me 8 pi, which is in fact the same thing that we got in the previous example. So that's probably a hint that we did this correctly. And that concludes this example.